In this lecture, again module number 1 of Engineering Mathematics 1, which is the expansions of cos n theta and sine n theta in terms of cos theta and sine theta. So the expansions of sine n theta and cos n theta, the powers of sine theta and cos theta, we need to have the expansions, binomial expansions for the expression cos theta plus I sine theta, the whole power n. So as we know, according to binomial theorem, a plus b the whole power n can be written as nc0 a to the power of n plus nc1 a to the power of n minus 1 b plus nc2 a to the power of n minus 2 b square plus etc. up to ncn b to the power of n by applying the same expansion, binomial expansion for cos theta plus I sine theta, and then by considering the value of a as cos theta, b as I sine theta, then we are supposed to segregate into real and imaginary part. Then we have to compare it with cos n theta and sine n theta for imaginary part and cos n theta for real part. So the same expansion we have to apply, and when we are writing the expansion, we have to keep in our mind that is the powers of I, which are nothing but I square should be minus 1, I cube should be minus I to the power of 4 should be 1, I to the power of 5 should be I to the power of 6 should be minus 1, I to the power of 7 should be minus I, and again I to the power of 8 should be 1, and I to the power of 9 should be I. So more than that, we won't be applying any of the expansion. So we will restrict up to 9th power of I, the values we should know. So when we are comparing the real part, cos n theta can be written as cos to the power of n theta minus nc2 cos to the power of n minus 2 sine square theta plus nc4 into cos to the power of n minus 4 theta sine to the power of 4 theta plus etc. When we are comparing on both the sides of imaginary part, sine n theta can be written as nc1 sine cos to the power of n minus 1 theta to sine theta, then this I should not be coming in the expression, minus nc3 cos to the power of n minus 3 theta sine cube theta plus nc5 cos to the power of n minus 5 theta to sine to the power of 5 theta plus etc. The same expansion, we are going to use it to find the expansions of the problems, whatever the terms it is given to us. So in this case, the first problem, they are asking us to find out the expansion of cos 5x, sine 5x, and tan 5x in terms of tan x. The third subdivision, we are supposed to find it out in terms of tan x. Again, since we are having only up to 5th order, we will have the Pascal's triangle up to 5th order. And we will be having the values of I to the power of 4. I is I square is minus 1, I cube is minus I to the power of 4 is 1, and I to the power of 5 is I. And the Pascal's triangle till 5th order we will write. The corresponding coefficients we are having 1, 5, 10, 10, 5, and 1. So just apply the binomial expansion for cos x plus I sine x the whole power 5. The corresponding coefficients we are having from the Pascal's triangle, the corresponding powers of I we are having already within the bracket. So in that way, if you are expanding it, cos to the power of 5x plus I sine cos to the power of 4 sine x minus 10 cos cube x cos square sine square x minus I 10 cos square x and sine cube x plus 5 cos x sine to the power of 4x plus I into sine to the power of 5x. Compare with the real terms on both the sides, which is cos 5x can be written as cos to the power of 5 minus 10 cos cube sine square x plus 5 cos x sine to the power of x. The same way, the imaginary part is sine 5x should be equal to 5 cos 4x sine x minus 10 into cos square x and sine cube x plus sine to the power of 5x. So we know the expansions for sine and cos already by comparing the real and imaginary parts. We got it already. So it's very easy to write down tan 5x in terms of tan. So tan 5x can be written as in the form of sine upon cos 5x. We know the values. Substitute the corresponding values in the numerator and denominator for sine 5x and cos 5x, the expansions. Then you're supposed to divide the numerator and denominator by cos to the power of 5 because the highest power is 5. We need to get the expansions in terms of tan. So sine to the power of 5x, it is existing in the numerator part. So we are dividing with the highest power of cos, the numerator and denominator by cos to the power of 5x. Then we are getting here as 5 tan x minus 10 tan cube x plus tan to the power of 5x in the numerator, and in the denominator 1 minus 10 tan square x plus 5 tan to the power of 4x. So this is all about your first problem. The second problem, again they are asking us to find the expansion of sine 6x and cos upon cos x in terms of sine. They are asking us to write down the expansion. Since the highest order in this case, you can observe it is 6. So we need to write the Pascal's triangle till the 6th order. The corresponding coefficients of 6th order will be 1, 6, 15, 20, 15, 6 and 1. And the corresponding powers of I you can write down. I square minus 1, I cube minus I to the power of 4 as 1, I to the power of 5 as I. And I to the power of 6 as minus 1. We need to find the expansion of cos x plus I sine to the power of 6, which is equal to, we know the coefficients from the Pascal's triangle. We know the powers of I from the bracket terms, which we have written it. So the expansion will be cos to the power of 6 x plus I, 6 cos to the power of 5x sine x minus 15 cos to the power of 4x to sine square x minus I, 20 cos cube sine cube x plus 15 cos square sine to the power of 4x plus I 6 cos x sine to the power of 5x minus sine to the power of 6x. We need to find only the expansion of sine 6x. So only the imaginary part should be compared, which is sine 6x. The terms which are containing I should be written over here only without I term, which is 6 cos to the power of 5x sine x minus 20 cos cube sine cube x plus 6 cos sine to the power of 5x. But they are asking us to find the expansion of sine 6x upon cos 6x in terms of sine. So what we are supposed to do it? We are supposed to divide on both the sides by cos x. So first you divide the entire term by cos x. So the simplified part for sine 6x upon cos x is 6 cos to the power of 4x sine x minus 20 cos square x sine cube x plus 6 sine to the power of 5x. But again, they are asking us to find the expansion in terms of sine x. So replace all the cos square terms by 1 minus sine square. So cos to the power of 4 can be written as 1 minus sine square, the whole square. Then cos square terms can be written as 1 minus sine square. Just remove the bracket and combine the powers of the like powers terms. Then we will be getting sine 6x upon cos x is equal to 32 sine to the power of 5x minus 32 sine cube x plus 6 sine x is the expansion for the term sine 6x upon cos x. The same way we are supposed to write it for the third sum. They are asking us to find the expansion of sine 6x upon sine x in terms of cos x. All the steps are same, but we are supposed to divide on both the sides of sine x is equal to that term by sine x. Then again replace sine square as in the form of 1 minus cos square term and combine the terms of the like power. Then the expression of sine 6x upon x can be written as 32 cos to the power of 5x minus 32 cos cube x plus 6 cos x, means sine 6x upon sine x in terms of cos. The simplified form is this. So this is all about your expansion of sine n theta and cos n theta in terms of, in powers of sine theta and cos theta.